The screwdriver, the most essential part of any toolbox, and one that our group member, Chandler, is missing. So we decided to make one for him. Nearly every product you buy has some kind of screw acting as a fastener. Screwdrivers come in many different shapes and sizes to account for the different screws. Our team selected a Phillips head screwdriver as our item to manufacture due to it being the most popular shape for screw heads. The main parameters the team took into account while designing this product were the materials, weight, design appeal, functionality, and ergonomics. The team first 3D printed the product part using the MakerBot 3D printer in one of the UGA labs. It was our first and only prototype. The main purpose of it was to ensure that the handle sizing was ergonomic for the typical human to use. Our team was also initially planning on using a CNC mill to manufacture the product. However, UGA does not have a machine that could accomplish what we were trying to do. Because of this, the team used a Dremel 3D printer to manufacture our product. Our final product resulted in a lightweight screwdriver that will work for the average everyday task and is easy to carry around with you. Its main drawback is its strength compared to a typical screwdriver.
Hello, my name is Chandler, and today I'm going to be going over with y'all a little bit about our design for our screwdriver. So this was something that I found to be a really fun project. So basically, it was a lot of revolving, extrusion, and filleting for this design, and for the most part, it was pretty simple. As you can see, there's a few of our dimensionings here, and let's see, the hardest part I found, and I had to watch a YouTube video, and I'll pull it up real quick, is the angles here. So in order to get the actual Phillips, I guess, bit, um, finding dimensions for it because it was hard for me to dimension it on my own. So I found a set of dimensions off of an old patent, and it had a few of the angles on there. So I grabbed those angles and then kind of based it off the size of the screwdriver in which we made, and then I was able to complete the head of the screwdriver right here. So then I did that for each side, and once I had that, one of the sketches was let me pull it up, was creating the shaft of the handle. And so here I just used a bunch of circles, and I extruded them to a certain length, and then I filleted in order to make the groove more appealing, so it wasn't just one cylindrical hole. And then from there, other than that, it was just a bunch of nitpicky little things. So, for example, like this right here, this was another example of using the revolution tool, but it was fairly simple as well. So here's actually where we started from. This is Will's drawing. And then final outcome after watching a YouTube video and playing with different sizings, this is our final product. This would be made out of a metal, and then this would be made out of a plastic. But for our cases, and due to time constraints, all we did was design it, and then we were going to 3D print it or CNC, get it CNC'd out. So that is our design. What you can do is go onto the Dremel website and download the software that is the 3D slicer. So once you download it, then you can open up, and once you open it up, you can go into Open File, and you can click on the design in which you want, and here I've already loaded it. So once you do that, you can click on your object and scale it or rotate it in order to match however you want it to be printed on the 3D printer. Then you can go on to Material, and whatever the printer has in it, select the material appropriately. Then you can go into Profile and click what kind of quality you want. I always recommend going with ultra quality. And then afterwards you can go into Print Setup, and here I don't change a whole lot. What you can do is go into Infill, and this would this basically changes the strength of your object. I leave the speed cooling um, as standard, and then you can click your supports. And what this does is it doesn't allow your object to sway or bend as the 3D printer is printing the object. So I highly recommend this and the build plate adhesion. So after you do that, what you can do is you can hit prepare, and this prepares your drawing, and there'll be a little button to download it. You can plug a USB into your laptop or computer and then download it straight to the USB drive. Once you have the USB drive, you can plug it into one of the Dremel 3D printers, and it will give you an option to click on the USB file, and then you can build your object, and it'll print it.
Most screwdrivers go through a generic manufacturing process that includes the following. First, steel wire is drawn to reduce its diameter to the needed production size. It is then annealed in an oven at roughly 1350 degrees Fahrenheit for 12 hours to increase the tensile strength of the material. The wire is then straightened and cut to the proper length, and then the tip is formed along with the wings that will go into the handle. This bar is then put into a furnace at 1550 degrees Fahrenheit. After the furnace, the bars are sometimes oil quenched. Finally, the bars are placed in a lower temp oven and baked to a specific hardness. The bar then goes into a nickel flash bath and is electroplated to give the screwdriver the shiny finish that we see. If the screwdriver is a Phillips head, it goes into a die where the tip is formed. Next, the handles are made from a mix of cellulose acetate and plasticizer. Pigment is added if a specific color is desired. This mix is forced through an extruder to form small pellets. These pellets go into another extruder that makes bars of 8 to 10 feet in length. These bars are cut to a handle length and go through an acid bath to receive a quality finish. Finally, the metal rods are pressed into the handles and assembly is complete.